Hi everybody! Today we're going to learn a little bit about derivatives. But first, you have to understand what the average rate of change is, and then we'll move on from there. So hang on. Now, let's say we have this beautiful little graph here, and you want to get an average rate of change. So, what you might do is, let's say your interval was from this spot here to this spot up here, and you want to see, on average, how far or what that angle is. Well, what you do is you find out how high it got here, how high it got there, and then how far apart it is here. So you're looking at this distance here, and you're comparing it with this distance down here, which is the top, y2 minus y1 that you might have heard in Algebra 1. You take f of b, subtract f of a, and then you divide it by b minus a. All right, here's your little formula. Remember that, okay? You're taking that guy, taking away that. It's a very short cut, little vast answer. Now, here's an average question. Find the average rate of change of f of x equaling that for the interval from 1 to 3. So, what we would do is we would go back to here and we would figure out our pieces. So, the interval is from 1 to 3. So, the last one is 1 and the first one is 3. So, we're comparing it out of a distance of 2. But, here's the tough part. We're trying to figure out with this formula of x squared minus 2x plus 4 from 3 to 1, so we're going to have to do two questions. We're going to have to solve two questions. We're going to find out where the line is at f of 3, and we're going to have to find out where the line is of f of 1. If f of x is x squared minus 2x plus 4, that means whatever you're talking about, whatever your x is, you take that number, you square it, you take away 2 of them, and you add 4. So if you were looking to find f of 3, you would find that would be 3 squared minus 2 3's plus 4. And if you're looking for the f of 1, you would take 1 squared, and then you would take away 2 1's, and you'd add 4 to that. So your answers here are 9 minus 6 is 3, thank you, plus 4 is 7. 1 minus 2 is negative 1, plus 4 is 3. I hope I'm right. This is live. This is all live, folks. This is live. Never done before. All right, so when you plug these back in, this one looks like it was at a 7, and this guy over here is up at a 3. So, all you're going to do next is you're going to go grab another piece of paper and say that the first one is a 7, the second one's a 3. So it went up 4, the rise over the run. It went up 4, and it went over from 3 to 1. Okay? And so your average rate on that interval from 1 to 3 is 4 over 2, which is what? 2! I can hear you all groaning and changing the channel already. Wonderful. Well, see, that's kind of nice and everything like that, but that's a short-term thing and that's very specific. Now we're talking about derivatives, which is when we're going to find kind of instantaneously what the change is. So what that slope looks like on that original line, maybe right here, would be this. That's your slope. Okay? But what we're trying to find now is what's the slope, not from here to here. What's the slope here? Derivatives. This is, first of all, this is the symbol you have. Okay? The symbol for the derivative of f of x is going to be this little kind of apostrophe looking thing up there. All right? And that represents sort of the instantaneous change at that moment. So if I were to draw the graph, what would the slope be at that exact moment in time? And it's kind of weird, but what you're going to do is you would have to take this little distance like we did before. We had f of a and f of b, but if we can bring the b part really close, where they're actually the same point, and we can figure out what happens next. But this is the formula, and we'll get to this in a second. But we're going to create this fictitious distance side to side that's called h, and we're going to shrink it, the limit, as it gets really close to 0. So that distance between the 2 points, f of a and f of b, and a and b, when a and b are 0 apart, and this is what your answer would look like. All right? So, second thing, there's some other symbols I want you to know of. So if f of x is also known as the y, then the derivative of the f of x has a few different ways to be written. You could put a y with a little prime next to it, little, what do you say, apostrophe. You could say the change in y over the change in x, or the change of the f of x compared to x, or the capital D, little x, little y. These are all different ways of writing it, so be careful and take a picture of the screen or whatever. Now, the instantaneous rate of change, as I said, we're looking for when the distance between those 2 points is 0, which would mean you're dividing by 0, so it gets weird, so that's why we have something called a limit, so you just follow the pattern. So, let's say we have this little line here, it looks pretty cool. I drew it myself, thank you. What if we wanted to find the slope at that spot right there? What would we do? Well, it's called a tangent. What you do is you'd have to kind of use a supercomputer to solve it or something like that. Or, you know, you use a ruler. Here's what it would be looking at for, what it would be looking like at 5. This is what it would be looking like somewhere around 3. So you can see as it gets higher and higher, the angle is different. So the angle is not the same at 5 in this line as it was at 3. So what you're kind of doing is approximating. At this moment, what I would say would be, let's approximate, so let's make this distance of 4. So from 5 to 9, okay, you go all the way up there, and your distance this way is 4, okay? And your distance up, we would measure, and we would compare, and that would give us this angle. That's not the right answer, is it? The angle is supposed to be something like that, right? But if we went from 5 to 9, that would be a pretty close approximation. At least, you know, better than nothing. But if we got closer, if we got smaller, the distance went to a 3, from 5 to 8, that angle gets a little bit better. And if we go to the 2, that angle gets a little bit better. And if we go to 1, from 5 to 6, that's a 1, the angle's a lot closer, until we finally go all the way down, where we're at that sort of imaginary place where it is a 0. So here's what we're going to do. Number 1. Oops. So number 1, let's say, example 1, let's say that the function itself is 2x minus 4, and we want to find out what the slope is at the point where the x is a -1. Well, what we would do, very simply, with all these papers in my way, typical Mr. Johnson. All right, so the first thing we're going to do is punch it into that formula. So you rewrite that nice little symbol, the derivative of -1, and you're going to type it in. This is the important part, LIM for limit, and then you're going to write that the h is going to get close to 0. That's the distance between the points side to side is going to be 0, or at least close to 0, because sometimes it doesn't actually exist because you're dividing by a 0 and blah, blah, blah. Who cares? Change the channel. But then you plug it in. And what you're doing is you're taking f of b and taking away f of a. All right? F of a, this is our a. A is -1. And dividing it by b minus a, which is how far apart they are in the first place. So we're going to call it h, and this is why you have to call it the limit, because you can't actually divide by 0. If you divide by 0, your paper will explode. Go ahead, try it. Try it. So, the next part is, how far apart are these from each other? Well, it's kind of simple, but you just take whatever point you are, and you're going that far ahead. You're going that much further. So if you were at -1 and you're that far away, you just add that number. So if this was a 5, you'd be at -1 plus 5. If this was a 27, you'd be at -1 plus 27. All right? Here's where it gets fun. Solve it. We know the function is 2x minus 4, so we have 2 of these minus 4. 2 times -1 plus h minus 4 minus 2 times times -1 minus 4. Okay, don't forget, that whole thing is being subtracted. And the whole thing will be divided by your best friend and mine, h. Now when that's all done, you kind of simplify it out. You get -2 plus 2h minus 4 plus 2 plus 4, all divided by h. But watch what happens, and this is going to happen most of the time when you have these cool questions. A lot of stuff cancels each other out. Plus 4 minus 4. Plus 2 and minus 2. So you're really left with this stuff. You have 2 times h divided by h, which at any moment, other than that magic 0, when you're dividing by 0 and it doesn't happen, every other time, what's that ratio? When h is 5, you have 10 over 5. When h is 12, you have 24 over 12. And every single time, you have twice as many on top as there is on the bottom, and that's the answer is 2. And that's what it is. It shouldn't be surprising, at least, because if you think about it, that original question is asking, what's the slope at that moment? Well, the slope is always 2 in this particular question. But wait, it does get more complicated. As I said, one more time, this is the slope. Okay? We're looking for the slope at any given moment, okay? Now, see, that was the little picture. I forgot to put the picture there. Makes sense, though, that the slope is going to be 2 no matter where I go on this particular line. But if I get a curvy line, what happens? What happens? You have to find the derivative. So if I want to find on this question where the y is x squared minus x plus 3, how am I going to do that? Well, it's the same exact way. It's a pain in the butt formula, but just plug it in and work it out, okay? So if our formula is, as I said, x squared minus x plus 3. Write that down if you don't remember. Then what you're going to do, if you're trying to find, for example, what the slope is at the point 1, is you have to solve this out. Because you're going to have the limit as h getting close to 0 is going to be the answer to this question. So you're going to have f of 1 plus h. Now, we said before, it was x squared, right? That's a 1. Minus x, which again in this case is 1 plus h, plus 3, right? So that's f of b. If you go way back to the start, f of b. That's the function, x squared minus x plus 3. So f of that number is blah blah squared minus blah blah plus 3, right? And you take away the other guy, the original, which was just 1. So you have 1 squared minus 1 plus 3. Okay? Now you're taking them away, so the signs are going to change. Okay? And that whole thing is divided by h. So when you go to the next level, visitors. Hello. So you go to the next step. 1 plus h, you're going to square that out. You're going to use the FOIL method. You're going to have 1 squared plus 2h plus h squared minus 1, because you're subtracting, minus h plus 3 minus 1 squared plus 1 minus 3, all divided by h. And watch how wonderful this is. A lot of things are going to cancel each other out. Minus 1 squared plus 1 squared. Plus 1, minus 1. Minus 3 plus 3. And then these guys are left. And some of them actually go together. So, and this is still in the bottom. You have h squared plus 2h, but minus 1h. So you're still going to have one of those h's left. And the whole thing is divided by h. Now before you say, I don't understand what that is, you can simplify that even more. Use factoring, that's opposite of distribution. If I gave you that, would you know that that's the same as that? Yes. But, like we did last time, you have this h divided by h part that's going to cancel each other out. So when h is a 7, you have 7/7 of that answer. When h is a 43, you have 43 43rds of that answer. But when h is a 0, even though it doesn't really count, that's why we're saying it's the limit as the h gets really close to 0. We're pretending that we can do this. We're pretending we can divide by 0. What's the answer? By the way, h is a 0 when we pretend h is a 0. If h is a 0, 0 plus 1 is a 1. All right? So what we've just found out is that at that moment, not because that's a 1, but because of the shape of the line that we're graphing, the slope when the x is a 1 is a 1. Now go a little bit further. Just find it in general. We're going to find the derivative in general across the board, so we don't have to do that each time. What we're going to do is we're going to plug it in once, use the x, and see how all the x's and all those type of wonderful things all cancel out, and then we have the derivative for the entire graph. All right? So don't forget, the original graph was x squared plus x, minus x plus 3, okay? So we're going to do that for every single x in all of, the world. One last time. So, the derivative is, it's the limit as the h thingamajiggy gets really close to 0. That's when those 2 points are getting really close together, and that line is perfect, what we want it to look like. The slope, there we go. Sorry, end of the day. So what we're going to do, take the function of x plus the change, and then take away where we started. All right, so we were at x, and went to x plus h. So the distance up and down, you got the answer there and the answer to that. And you subtract x plus h minus x, which is back to h again. That's what we've been doing each time. All right? Now, our function was x squared minus x plus 3, so we're going to do that again. So the limit as the h gets close to 0 of x plus h squared minus x plus h plus 3 minus these whole things x squared minus x plus 3 all divided by what? Thank you, h. So here's where it gets fun. X squared plus 2x h plus h squared. Foil. First, outside, inside, last. Good. Minus x plus, sorry, you're subtracting the whole thing, so you're minusing your x and you're also taking away the h. Apologies all around. Plus the 3 minus the x squared minus the negative, so plus the x, right? We're taking that away, and then we're taking away the 3. So that's just minus 3 divided by h. Holy macaroni, Mr. Johnson, you're forcing it. I don't care. Minus 3 plus 3. Minus x squared plus x squared. What else we got here? Plus x minus x. Okay? And we're all done. We have this guy, and this guy. Kind of like what happened last time, but as I said, we're doing all of them at the same time this way, not one at a time. And you get this. H squared, right? Plus 2x times h. And you're taking away an h. Whole thing divided by h. All right? Do your sort of undistribution called factoring. You're going to factor that out. They all have an h in it. So we can say it's h times, that would be h plus 2x minus 1, thank you, not 0, divided by h. And these two things are going to cancel each other out. And don't forget that h is a 0. So our final answer is that every single time the slope is actually equal to 2x minus 1. So when the x is a 0, the slope of the line is 2 times 0 is negative 1. But when the x is a 5, the slope is what? 10 minus 1. Thank you. 9. All right? And this is how it all works out, and it's really fast this way. It's really quite wonderful. And if you think about that that last question that we were looking at, when we had said, what was the answer to when the x was a, where are we? When the x is a 1, we did all this work and we found out that the answer was a 1. Well, if the x was a 1, what's 2x? 2 minus 1 is a 1. So we can just solve all of them that way. All right? Now, there's a pattern, which I will not show you today.